All right, guys, let's get started. Uh, you're not going to see me so much. You'll probably see the top of my bald head a little bit. Um, but anyway, welcome to class. This is our first video lecture. And we left off, if you follow along in the syllabus, and I posted an updated syllabus now. If you follow along in the syllabus, then you know that we are starting 4.1. So we're kind of taking a little detour. We left off in 7.2 the last time we saw each other, and now we're kind of going back. We're going to do 4.1, 4.2, and 7.3 this week. So the reason that we want to do this is because in 7.1, or in chapter 7, I kind of mentioned that there are a lot of phenomena in the real world that follow a bell-shaped distribution, right? So they're normally distributed, in other words, right? So another way to say bell-shaped distribution is to say normal distribution, right? So there are a lot of things that are normally distributed. However, we want to be able to figure out exactly when something is normally distributed. Now, we can do this. We've talked about in the past that you can make a histogram and you can kind of tell if something's normally distributed kind of by looking at it. But we want to get nice numerical summaries that will tell us when something is normally distributed as well. That'll just make it more mathematically rigorous. It'll be a more mathematically rigorous way to determine whether or not something's normally distributed. Well, it turns out that the way we determine that something is normally distributed is very similar to the way that we determine if there's a linear correlation between two variables. And so we're going to talk about linear correlation in chapter 4, right? 4.1, 4.2. And then we'll talk about how to assess normality in 7.3, okay? So 4.1. By the way, you're going to want to have your notes out, and so you can take notes on these handouts that I printed off, or not that I printed off, but that I posted on Canvas at the beginning of the semester, so that you have them. If you don't have a way to print them, you can come to campus and print on campus. If you don't want to come to campus to print your notes, you can actually write on these in OneNote. So as students, you all have free access to OneNote. You might want to familiarize yourself with that, but you can write on these PDFs in OneNote that way, or you might have some other program that'll allow you to write on a PDF. Worst case scenario, you can always just pull out a sheet of notebook paper and just refer back to the problems that we're going to be doing on the handout, right? Like some of you have been doing that all semester anyway. But without further ado now, let's take a look at linear correlation. So in the past, we defined response and explanatory variables. We're going to just review that a little bit, right? So remember that the effect is the response variable and the cause is the explanatory variable. If we want to determine if there's a relationship between, a supposed explanatory and response variable, then one way that we could kind of get our hands around that would be to draw what's called a scatter plot or a scatter diagram. So in a scatter plot, each individual is represented by a point. The explanatory variable is plotted on the x-axis, and the response variable is plotted on the y-axis. It's not always easy to tell which one is which, and honestly, that really depends kind of on the researcher and what the researcher is trying to determine, right? So we'll look at some examples of this so that you get the idea a little bit. But let's take a look here and just work on making a scatter plot. So this first example says, construct a scatter plot for the data obtained in a study of the number of absences in the final grade of seven randomly selected students from a statistics course. See, now this example probably was more appropriate when you were all in class physically, right? But anyway, we'll just go with it. It's all made up anyway. I mean, none of this data is real. But okay, so we want to make a scatter plot of this. So literally, we're just going to plot these ordered pairs on a set of axes. So you've been doing this kind of stuff all your life. Well, maybe not all your life, but at least since you started algebra, you know, in 8th grade or 9th grade or whenever it was. So let's give ourselves a set of axes. We need an x-axis that'll go up to 15, and we need a y-axis that'll go up to, it looks like 90 is the largest one. So, so here we go. I need to go up to 15. I might go in increments of 2, so like 2, 4, 6, 8, 10, 12, 14, and 16. Well, I guess I could have spaced them out a little bit more, but that's okay. And this is the number of absences. Okay. Then on the y-axis, we're going to put the final grade. Since it needs to go up to 90 and it's starting all the way, well, it starts at 43. So I'm going to give myself a little symbol here that lets me know that, okay, I'm not starting this right at 0. But I think what I'll do is start at 40. I think I'll start at 40 and I'll go up in increments of 5. So I'll start at 40, go up in increments of 5 until I get to 90. And let's grab my pencil. Okay, so it's 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, and 90. Maybe I'll just label the 50, 60, 70, 80, and 90, and not the ones in the middle because it'll clutter up my picture too much. Anyway, this is the final grade here. Final grade. Okay, and now what we're going to do is we're just going to take each of these points and plot them like an ordered pair, right? So we're going to plot the point 6, 82. So 6 and then 82. You got some practice doing this in the Alex course, right? Then we have 286, 286, right about there. 15, 1543, maybe somewhere around there, and so forth. I'm going to stop talking and just draw. Okay. So you get a picture that looks kind of like that. If you're not, see, now here's the beautiful thing about these video lectures. If you're still working, pause the video. Pause the video and then you can finish it up. Anyway, but we should give this thing a title. So I'm going to call this, absences versus grades or something like that. I didn't give myself enough space up top to center the title of my graph, but there you go, right? That's a scatter plot or a scatter diagram. I'm not sure which term your book uses, okay? So that's that. I'm going to move on to the next page. I'm going to stop this video and start a new one so that it doesn't take so long for it to upload to YouTube.